Okay, this is Geometry, Chapter 1, Section 3, Measuring Segments. Postulates, and more postulates. So, postulate 1-5 deals with something called the ruler postulate. And the ruler postulate POS means postulate. The ruler postulate says that every point on a line can be paired with a real number that makes one-to-one correspondence. So what that means is that we have some point A, some point B, uppercase A, uppercase B. Remember that the uppercase are ways of denoting a location, right? What the ruler postulate says is that every point can also be correspondent to a coordinate, So some A or some B. So if you think about that, what does that mean about coordinate? Well, coordinate is just some distance measured on a number line. Some distance measured on a number line. So if I was to say this is 0, 1, 2, that coordinate would be 2, -1, -2, -3. That I would say that coordinate A is equal to -3 on some number line, while coordinate B would be equal to some 2 on a number line. So that's all the ruler postulate says, is that a point can be corresponding to a coordinate that can be measured on a number line. That's all the ruler postulate says. And the way that we find the distance of a coordinate, so here's our A, here's our B. The way that we can find the distance with coordinate A and coordinate B, notice that the location is labeled A and B uppercase, and the coordinates are lowercase a, lowercase b. So the distance of AB is equal to the absolute value of the coordinates A minus B on the number line. So we said that this was -3 and this was 2. Well, if I wanted to know the distance, it would be -3 minus 2, and I would take the absolute value. That would be -5 absolute value. So then the distance of A and B would be 5. And again, you can use the number line to prove that. So this would be -2, -1, 0, 1, 2, right? So you just count the ticks, right? 1, 2, 3, 4, 5. So that's to find the distance between 2 points on the number line. They give us an example here. They want to know what the distance it is between UV and SV. So U is equal to 10. V is equal to 14. And S is equal to -4. So looking at the distance of UV, the first one, UV is equal to the absolute value of U minus V, so that would be 10 minus 14. So 10 minus 14, which is the absolute value of 4, which equals 4. So UV equals 4. Then we have SV. That equals the absolute value of -4 minus 14, which is a -18, absolute value, which equals 18. So SV equals 18. Remember that if you're wondering why it's the absolute value, there is no such thing as negative distance. Distance is always positive. The only thing that's negative or positive is the direction that they go. But distance is always positive. And then if you wanted to confirm with the number line, you can always count. So 1, 2, 4, 6, 8, 10, 12, 14, 16, 18 from S to V, and then 2 and 4 from U to V. So it works out. Now we have postulate 1-6, which is the segment addition postulate. And the segment addition postulate says that if I have three collinear points. So I have point A, I have point B, I have point C. Then I have the distance here, which is AB. I have the distance here, which is BC. And then I have the overall distance, which is AC. So the overall distance is AC, right? And I have these two little segments, right, from A to B and from B to C. I can say that the overall segment, the biggest segment, AC, is equal to the sum of the smaller segments. So AB plus BC. So the big segment, the overall segment, is made up of adding the smaller segments together. And that is the segment addition postulate. Let's look at an example. So for number 2, we are given JKL yeah, J K L. We're told that KL is 7x plus 15. We're also given that JK is 4x plus 6. We are told that JL is 20. 120. So they want me to find JK and KL. Find JK and KL. So Uh, knowing the segment addition postulate, I know that the bigger segment, JL, is equal to the smaller segments added together. So it's equal to JK plus KL. Well, I know what JL is. I'm going to use substitution. JL is 120. I know what JK is. JK is 4x plus 6. And I'm going to add what KL is. And KL is 7x plus 15. So now I can combine like terms. So 120 equals 4 plus 7 is 11. So 4x plus 7x is 11x. And then 6 and 15 is 21. Subtract 21 from both sides and I get 99 is equal to 11x. Then I divide both sides by 11 and I get that 9 is equal to x. So we found what x is, but that doesn't tell me the distance of JK and KL. So I'm going to substitute x in for or 9 for x when I'm trying to find out what JK is. So I'm subbing here. So that's going to equal 4 times 9 is 36 plus 6. So JK equals 42. And then for KL, I'll have 7 times 9 plus 15, which is 63 plus 15, which is 7378. And if you want to check if it works, you can always add 42 plus 78. And that equals 120, so it works. So we had to use the segment addition postulate, substitute, which is JL, the whole overall big segment is made up of adding the smaller segments on the same line. JK plus KL, I substituted 4x plus 6 for JK, 7x plus 15 for KL, and then 120 for JL, and then solve for x. After I solved for x, I substituted back into the equations for JK to get JK equal to 42, and I sub 9 back into the equation for KL to get that KL equals 78. And next we have the difference between congruency and equal. So we have two segments, AB and CD. We're told that AB is 1 inch. We're told that CD is 1 inch. We have the same two segments over here, not to scale, AB and CD. We're not told what length they are, but we have these two markings which tells me that they are of the same length. So since I know that AB and CD are of the same length, I know that they have the same shape and size, I can say line segment AB is congruent to line segment CD. Here on the left, since I know they're the same length, I can say that the distance between A and B is equal to the distance between C and D, the measure. So I have a numeric measure, an actual distance, so I can use A, B, and CD. Notice I don't have the segment sign on top of them. And since here I don't have a numeric measure, I just know that they're the same size or the same length. Without knowing the actual measurement, I can say that they are congruent to each other. If AB is equal to CD, then AB is also congruent to CD. So if they have the same numeric value, they also have the same size and distance or in shape when it comes to a line segment. Alright. So we have this number line, and they want me to find out if AB is congruent to DE. So we have AB, A equals -2, B equals 3, D equals 10, E equals 14. So I'm going to use the distance equation and say that AB is equal to the absolute value of -2 minus 3, which is the absolute value of -5, which is 5. So AB equals 5. I'm going to say that DE is equal to absolute value of 10 minus 14, which is absolute value of 4, which is 4. And D equals 4. So since these two segments are not equal to each other, I would say that AB is not congruent to DE. AB is not congruent to D because the length of AB is 5 and the length of DE is 4. Alright, so for this last problem on the comparing segments, they give me a scenario of A and C. And they want to know if distance is interchangeable. So let's take a look-see. C is equal to 5. So what if I was to get the distance of AC, right? Just like we did before, it would be -2 minus 5, which is -7, absolute value, which equals 7. So the distance of AC is 7. But what if I was to reverse the order? What if I could find the distance of CA? Will I still get 7? I don't know why I put that on top. Well, let's see. So then this would be 5 minus -2. That's the same thing as saying 5 plus 2, which is the absolute value of 7, which gives me 7. So CA would also be 7. So it doesn't matter the order of the endpoints. If you plug them in correctly in your equation, you should still get the same distance. Okay, we have the midpoint and the segment bisector. So a midpoint is a segment, is a point in a segment. So I have A and I have B. I have some point in the middle, call it point M for middle, such that when it's in the middle, it's going to cut these two guys completely in half. So this and this are the same, they're equal. So segment AM is congruent to segment MB. So we would then say that M is the midpoint. And I'm going to put MP for midpoint. M is the midpoint. And it's the midpoint because it's the point in between, in the middle of A and B, so that it cuts these two guys in half and make them congruent. So this guy in the here, if we were to put a number here, this would be 5 and that would be 5. That's the midpoint. Now with the midpoint we can have things that can cut the midpoint or cut at the midpoint. So we know that M is the midpoint, but we can have things that can cut the midpoint. So for example, what if I had some line, and let's call it line L. Well, line L would be the segment bisector. The segment bisector. So what's the segment bisector? The segment bisectors are geometric figures that is cutting the segment in half. So in this case, the segment bisector could be a point. The segment bisector could be a line. The segment bisector could be a ray. The segment bisector could be a line segment. And the segment bisector can be a plane. So point, line, ray, segment, actually, or plane, that divides the segment in half. That is the segment bisector. So midpoint, the point that's in the middle, segment bisector, the geometric figures that cuts it in half and puts it into equal segments. Bisect itself, bi means into two, sect means to cut. So to cut into two, and to cut into two equal parts. And then we have uses of the midpoint. So how can I use the midpoint in a problem? So I'm told that U is the midpoint of TV. So here's TV. T U V. I'm told that U is the midpoint. So since U is the midpoint, these guys are equal to each other. They're congruent. I'm told that TU is 8x plus 11. I'm told that UV is 12x minus 1. So TU 8x plus 11, UV 12x minus 1. Since I know that they're congruent to each other, I also know that they're equal to each other. So I can say that TU is equal to UV. And then I can substitute. And I can say that 8x plus 11 is equal to 12, x minus 1. And then I can solve for x. I can subtract 8x from both sides, and I can have 11 equals 4x minus 1. I can add 1 to both sides, and I can say 12 equals 4x. Then I can divide by 4 on both sides, and I can say that x is equal to 3. But that's not what they want. They want to know what the distance of TU is and what the distance of UV is. So I'm going to substitute 3 for x wherever I see x. So it's 8 times 3 plus 11. 8 times 3 is 24. So TU equals 35. UV, that's 12 times 3 minus 1. This hopefully is also 35. 12 times 3 is 36. And 36 minus 1 is 35. So UV equals 35. And since they're both 35, that confirms that they're equal, therefore they're congruent. Thus, U is the midpoint. That is section 1-4. Hope you have a great rest of your day.